All right, we're almost there. So we're here at the Developer Summit. Thank you all for coming. We're still having people stream in. So I think we should maybe start the presentation. So we're at the Developer Summit. So there are a couple of words here, web services and APIs. I'm sure you're all familiar with both those terms. The OGC stands for Open Geospatial Consortium. It's a standards organization, especially in our domain, that works to put a lot of data, metadata, and web service standards together. So we're going to be talking about OGC web services and their move to the OGC APIs. Before I begin, I should introduce myself. I'm in product management. My name is Satish Sankaran. I lead a lot of the open platform initiatives. Hisham, you want to introduce yourself?
I'm Hisham Masi. I work with the native SDK.
Richie Carmichael, I'll work on the Maps SDK for JavaScript team.
Okay, again, since it's a developer conference, me in product management, I'll do a short introduction to set the ball rolling and then hand it over to Hisham and Richie so they can actually show you the working parts of the system here. Okay, so simple agenda, a little bit of a exposure to how ArcGIS is an integrated and an interoperable system. We're going to talk a little bit about the OGC standards that are currently being developed to make this conversation fit within the time, as well as to kind of keep the focus. It's going to be on what's called the OGC API features. So that's the one that we're going to really focus on. Given the many initiatives happening within OGC, we're going to try and keep the focus on OGC API features and a bit on the OGC API tile specification. And then, like I said, Hisham and Richie are here, so they're going to talk more into the details, making sure that the developers in the crowd are happy with what you get to see here. Okay? So this slide has been repeated multiple times as part of this conference and before, so you understand this. ArcGIS is an integrated enterprise system. Fundamentally, we've got multiple components, servers, portals, desktop, mobile apps, and web apps. So obviously, it's as an integrated system, they all come together and work really well to, satisfy your workflows, right? The servers serving out the web services, the portal helping you with the collaboration sharing parts, and you have the ability to consume those from a desktop or a mobile environment or web APIs. But what is more important for this presentation, if you can go back to the previous one, is that ArcGIS is an interoperable system, right? So if you're living in an environment that is more heterogeneous, we're not talking of an organization that is purely using only Esri or ArcGIS systems, then we're talking about how does the ArcGIS system fit within that larger enterprise. So you could have servers that are not ArcGIS servers. You may have desktop implementations that are using QGIS, GVSig, and so on. You could be using web apps that are built out of open layers or leaflet. So in this environment, interoperability is key to make sure that the services that might be served out are consumable by the applications that are part of this environment, right? So a lot of this is possible using the GeoServices REST API from Esri, but we're going to focus on the open standards that come out of OGC. And if you're aware of the last 15, 20 years of OGC stuff, there's been the older OGC web services, and now we're going to talk about the newer open OGC API parts. Okay. The old OGC stuff, WMS, WFS, WCS, Web Map Services, Web Feature Services, Web Coverage Services, and so on. I hope some of you are familiar with that. Couple of years back, OGC and W3C got together and tried to reimagine, if you will, or rethink how best to deal with problems of spatial data on the web. How do you, what are the best practices to deal with it? And they kind of categorize this in terms of a good trust framework. How do you make it discoverable? How do you have them to be interoperable and so on and so forth? As part of this effort, some of the new open API or OGC API concepts were born, right? So OGC now has a variety of new OGC APIs for solving mapping problems, for mapping, for features, for tiles, for processes, for coverages, and so on. So you can find more information at the URL link below. What is important here is to note that there are a variety of these that are approved standards, and there are a lot of things that are still in the making, right? So the features at that very end is an approved standard. The tiles is an approved standard. The EDR, which is the environmental data retrieval, is an approved standard, and so on. So again, like I said, we're going to focus on just a couple of these so that we can keep it clean and easy to understand. So these are OGC API standards, and then there's a question of how do we deal with it within our implementation. So if you look at the OGC API features, it's a standard which has its own extensions. So some parts of the standard are standardized. They've been released to standards. Some of it is still in a draft mode. So you see OGC API features with the core and the CRS parts that are completed standards. The filter parts and the transactional aspects are still in draft. And same thing with tiles, and then there's OGC API records and so on, right? So take a photograph if you want of some of this stuff, but the bottom line is we spend most of our time implementing stuff that is already a standard, and in some cases, if you are comfortable with even the draft specification, we've started some work on those, and that's why it says in progress on some of these things. With that, I'm going to hand it over to Hisham to kind of focus on the API features part. Hisham?
So this part of the presentation, we're going to focus on hosted enterprise OGC FeatureServer. We're going to talk a little bit about Open API. And finally, we're going to end it with a deep dive into the ArcGIS native API. This is a question for you, actually. How many of you are familiar with or using ArcGIS API features in your application? Let's start familiar with first, by the show of hands. Interesting. Almost half of the audience. How about actually using OGC API in your application? A little bit less. Thank you. Okay. What is OGC API features? It's a complete rewrite of the WFS standard. It's not a new version. There is no mandatory encoding. HTML and GeoJSON are just a recommendation. No get capability document. Open API specification 3.0 and the conformance page, as you're going to see down the road, replaces the get capabilities that you might be familiar with to get the metadata or what this service is about. If you want to learn more about the OGC API features, the standard is out. This is the link to it. Now, from an architecture perspective, we have the landing page, which is the base URL that you share with your customer or you're interested in. And we have relative path that allows us to dig into the conformance page, the API definition. And we're going to see all of these down the road. The collections and each collection, think of it as a layer or a set of features. And you can even drill down into the feature ID and get one polygon or one point with this architecture. On this slide, I'm going to share with you 3 different ways of exploring an OGC API feature service. From the landing page, you can assume a preset pattern. As you can see, you can go to drilling down into /collection item feature ID and navigate all the way to get, for example, the JSON that programmers might be interested in. Now, this pattern is recommended, but I've seen that not every service is following it. To be more secure, you might want to get the landing page links to know where the collections are, where the features are, or where, if someone want to deviate from this pattern, can. Another way of exploring the API is the Swagger UI, which is the standard for open APIs these days. And I'm going to talk a little bit about Swagger Hub, which is a portal for registering public open API. If you have a server, you register it there, you let people know and learn more about it. So bear with me, I'm going to get there and talk about all of this in a minute. So this is not only applicable, what I just told you about, for OGC API features. Other OGC open API like tiles, styles, share the same pattern or the same architecture in terms of discovery and getting the information that you need. So they use the same open API to visualize and interact with API resources. These are common patterns. You've seen here, this is the same data set, agriculture, surface. I'm going /items to get the items, /tiles to get the tiles, styles to get the styles, later on maps, and so on and so forth. Same architecture, which make it super easy. Now, this leads us into a demo where I'm gonna show you what I just spoke about. So let's start by opening this page, which is the link that I showed you. So this is the landing page for our Portland 1 OGC layer OGC FeatureServer. It's a hosted service. We're gonna talk about it in a minute. I'm sure, how many of you is familiar with this look, like when you hit it on the browsers? Thank you, many of you here. So once you have, you hit the landing page, you can see here, we have an API definition, conformance page collection. I'm gonna try a couple of things here in the browser. So I'm gonna go /conformance to see what are we supporting here. You can tell that our server supports core 1 and core 2, so we're still in part 1, part 2 on the server side. But if you go into things like data, which is a very mature service, and you hit /conformance, if I can write conformance right, you can see that this landing page supports many things. It supports core 1, core 2, 3, part 3, and so on and so forth. So you can also go, and let's go back into what we've been looking at here, and hit the collection page. It's gonna give us the JSON. We have what you have seen before this is an HTML view, which it's up to you how you wanna do it. But this is the JSON view that shows all the collections that are available. With that, I'm gonna switch gear and start on the same service, talk a little bit and show you the Swagger interface. So to go there, we're gonna hit the API document, which takes /API, and it's gonna take us there. So this is a great way of exploring and interacting with the service. I'm gonna start by getting some features from a collection. I'm gonna pick collection number 1, which happens to be, I think, building footprints here. And I'm gonna hit execute. And you can see that I got a 200 response, most important of which is this request URL. What I usually do to try it out, I grab it from here. and let's open Microsoft Edge quickly, put it here and hit enter. Notice that I got 1900 polygons back by exploring this one. If I want to put a bounding box around some area, I can use that same interface to do so. So I'm gonna go back there, and notice I have here a bounding box. You can read about it. Only features that have a geometry that intersect the bounding box are selected. So let's add an item and play with it a little bit. For that, I have some coordinates here in my cheat sheet file. So I'm gonna grab this, min x, min y, max x, max y to define the bounding box, put it here, make sure I grab the all of it. And now, remember last time we hit it without any restriction, without the bounding box, we got 1900. Now I'm gonna execute it one more time. And I got 200 response. Let's take that and notice the pattern. It added automatically the bounding box and the coordinates that I add. I'm gonna put it in the same browser. Now let's do a new one and hit. Out of the 1900, the one that are intersecting the bounding box that I put are only 25. You can see that and drill down in each of these features. I'm gonna show you one more thing here, which is the Swagger Hub. I spoke about a portal to advertise your Swagger API and learn about it. This is the Swagger Hub. I'm gonna search for, is there anyone out there talking or have something about OGC API features? And you can find our friend here and who already have a beautiful Swagger Hub documentation that tells you section by section about the API. It's a great way to learn about it, understand what it is, what the collections are, what each of the bounding box examples and stuff about that. I encourage every one of you to play with this. It's a beautiful utility available to you out there. Now back to the presentation. So by now, we spoke about the architecture or how we explore things, how to publish things on our servers. There are two ways of doing that. We can publish a hosted OGC feature server online. The one I was playing with, it was one of ours. And you can see that's published there. It's a cloud native implementation. Many optimization that we have with our ArcGIS feature server has been ported into this server. And you have the similar publishing experience. So you can start using a shapefile, a file view database, convert it to a ArcGIS feature service, and from that, you can create an ArcGIS OGC API feature service. We name it an OGC feature service. Look at the difference. The first one is an ArcGIS feature service. The second one is the same base. It has an OGC feature in front. This makes it an OGC API feature service. The publishing steps, are exactly the same for WFS and OGC FeatureLayer, and you can look at them here. Step number 5 actually look at how close they are. All the previous steps and the following steps are the same. You also can publish an enterprise OGC feature server. You can only use ArcGIS Pro, and you can only publish to an enterprise portal at the moment. To do that, you need to go into ArcGIS Pro, go under Share. You load your layer into the map. This layer can be coming from a file view database, from a shapefile. Once you have it, this feature layer in your ArcGIS Pro map, you publish it, you share it as a web layer, and you publish the web layer. I'm gonna draw your attention to a couple of things. you need to go onto the Configuration tab and click on OGC Features. You have several options to publish in OGC FeatureServer. The steps are available here. They're straightforward to follow. In ArcGIS Pro 3.2, we recently added map tiles. So if we provide a landing page for a server, and that landing page supports both. So on the conformance page, you might see features and tiles. We automatically discover that, and you start by putting the root, as you can see over here. After that, automatically ArcGIS Pro will discover that we have a feature-based and map tile-based services. You can drill down into each one of these and select the layer. In the case of features, it would be OGC API layer. In the case of map tiles, it would be a map tile layer, and add it to your ArcGIS Pro. Notice here I'm adding blue marble into the map. I turned the base maps off. Blue marble here is not the base map. It is actually a map tile layer. And this is new in ArcGIS Pro, our support for map tiles. The ArcGIS Mapping SDK is available for you to reduce the complexity of working with OGC FeatureServer. And you have two choices, either use the native SDK or the JavaScript. It's easy to integrate because you're familiar with map and scene. You can add it as a layer into our map, into our scene, and so on and so forth. And we are advertised as a client library on the GitHub for the OGC API features, as you can see there. We are listed under native API library and JavaScript API, both the JavaScript API and the native one, which supports many languages, and we'll talk about that in a minute. This leads us into the native API part of our presentation and the support for OGC API features there. A little bit, this slide gives you a quick introduction on what are the different 5 SDKs that we support with our native SDKs and platforms. So we have .NET, Java, Qt, Kotlin, and Swift. Same capabilities, built on common runtime. We support 5 platforms. They're listed over here: Android, iOS, Linux, macOS, Windows. And some of them are cross-platforms. And all of them, we support part 1, part 2, and part 3. I know part 3 is still in draft, but we wanted to get into it as early as possible and support it. And we'll look into how you can make use of that and leverage it. This is our API. We have OGC features, new classes, OGC feature service info, collection info, feature table. That's it. All these 5 classes allows you to interact with any OGC feature service. Let's start by browsing, or if you have a landing page or an endpoint, you want to know what are the collections that are available there. To do that via our API, you can get into a OGC feature server. You put the URL, which is the base URL there. You load it. Once you load it, you get to the service info. We collect all the metadata behind the scene for you, and you can add the feature collection infos into a list to list all of them. And for that, I'm going to show you a quick demo. I'm going to use one of the existing sample application online, and I encourage you to play with them. They're fun to play with. They're automatically there for you. You can look at the code and interact. And I have here one that's called Browse OGC API Feature Service. You can see here I'm browsing for the data, and I can click on one, but I'm interested in browsing into one of ours. So let me try Portland, the one an hosted feature server. And I'm gonna put it here. and hit load the service. You can see that all the collections are listed. I'm going to click on building and load selected layer. And here you go. You loaded it, you can look at it and see what's going on there. The beautiful thing about working with samples is that you can go into descriptions of what this code is about and what it's going to do, and look at the source code. Straightforward. The snippet that you saw on the slide is taken from here, step by step on how to load the service and put the URL and play with that. Next, let's see how we can create an OGC API feature table. For those of you who are familiar with the ArcGIS feature table or a WFS or OGC API features, it's the same business here. You create an OGC feature collection table, which is a feature table or inheriting from a feature table from the service itself. So the code is straightforward. My feature table equal OGC feature table collection table. This is the OGC API features table. I pass the landing page and the ID. I'm interested in the collection ID, which is a layer ID. Here is the layer name. And now, once I have a feature table, if I want to, I can play with it all day long, but if I want to add a layer to the map, I want to create a feature layer from that OGC feature table. And to do that, I can pass an OGC feature collection table to a feature layer and create one, add the feature layer, which is now the collection, to the map or scene. In the example here, we're panning, zooming around the bounding box, and we're bringing more data. Remember that we only support manual cache in this case. This populate from service, you call it from map view navigation completed event. This is the visual extent. False means you want to keep on adding to the table when you bring features into your view. Null means bring me all the fields. If you want specific fields, you can populate that with name and, let's say, type or something. And with that, I'm going to show you quickly a quick demo on how this is going to perform. Notice that I'm going to be working with a data where the item count here is almost 700,000 points. So I'm going to run it automatically so you see the demo here. Control 5. Let's run it. Okay. So automatically here, I'm pulling 5,000 points. But look what happens when I start panning and zooming in the extent. I'm going to zoom automatically into this small area. And now it's going to take the bounding box of the screen and pull 5,000 points from here, because I'm not interested in pulling all the 7,000s that you've seen. Now, if I zoom back, you notice how dense this area is going to appear. You see how many points pulled in this small area? Let's zoom another area here. And now automatically it's going to go and pull more data that's clipped to this extent. When I move back, this could be my area of interest. I built that programmatically just to give you an idea that you can use our API to build your own experience around navigating into data sets that are huge. Back to the presentation, and now I'm gonna draw your attention to the many parts that are available on the GitHub website, and I encourage you to go there. You'll see, for example, something like the filtering part 3 is still in draft. The schema, they made a separate part of it. Everyone can participate there. I encourage that you go and play with it, see what issues the community is dealing with and they're trying to resolve. Schema is a big thing for whoever want to build a table-based, if you want, solution on the client side. In the beginning, this wasn't defined, so we were inferring the type from the first 10 fields or so. It's still not fine, if you want final, it's getting finalized, but you can read about it, and it's close to being final in these two documents, in part 4 and part 5. And the pattern that is now the community is settled on is that you go into the collection, let's say, I don't know, airports/schema. This is where you read about the schema, and this is an example on the right, like you get all the type of the fields that you might be interested in. I want to warn you that not all services support it yet, so be careful with that. In my implementation, I have a fallback mechanism where I do hit that schema. If I don't find it, I do the inferring. This leads us to filtering. I'm going to talk to you a little bit about CQL2 and how it differs from CQL2 JSON and where we support it in the native SDK. CQL2 is adopted by, it's mandatory actually. It should, any implementation of OGC API features need to support CQL2, whether it is text or JSON. I have here a pattern of, this is a field name called fcode equal blah. The filter lang is CQL text, it's the default. If you don't provide it in your URL request, it's gonna default to it. So this will yield the same as this the same result as this JSON. I believe the transportation ground has around 4,000. Here I'm limiting it to 100, but I'm filtering on this only. Look at the pattern used in the CQL2 JSON. Here, if you want to use CQL2 JSON, you have to explicitly put in filter lang equals CQL2 JSON. In our API, you need to feed this into the where clause on the query parameter. So you can put the CQL text or as is, just take it, put it there, the escape sequence, you put through and it populates everything. That leads us to another demo. So with the CQL filter here, we're starting with hitting like these. I told you there are like around 3,000 here lines. I'm gonna start by showing a subset of those. But notice what I did also, I did like a date time extend. I'm filtering based on time as well between this and this, and I got only 28 features returned. I can do something like AP, what is that? And hit it one more time, and now I'm gonna get 1369 because we have more of those there. You get the idea here. Behind, if you want to look at the code, look at this. I was experimenting with all of these in the text. This is available for you right now to go and explore and learn about it, well documented. I encourage you to look at these live samples online. In ArcGIS Pro, there is a way of also using the SDK for .NET over there. You can add a button, like if you're familiar with that. The only difference here, I'm highlighting it, is that it has to say OGC API equal true. You click that button, it automatically drills down into the collection you need and adds it to ArcGIS Pro. And with that, I turn it to Richie to talk to you about JavaScript and the OGC web API.
Great. Thanks, Hisham. Yes, my name is Richie Carmichael, and I work with the Maps SDK for JavaScript, and I'll be talking about OGC. So just to start with, we support a number of OGC standards, including WCS, WMS, and WMTS. So we support all versions of those three formats. For WFS, we only support the most recent version, version 2, and only those services that have GeoJSON output format. They're all supported in 2D and 3D, map view and scene view, with the exception of RSS and KML. So for the rest of this presentation, I'll be concentrating on OGC features. So just like the other products, we support Part 1 and Part 2. Part 1 was, of course, the core specification. Part 2 allowed us to specify coordinate systems. And this is very important for us because most maps are in Web Mercator. So with Part 2, we're able to send an extent to the server in Web Mercator, and we can also instruct the server to give us back geometry in Web Mercator. So that saved us the effort of doing client-side reprojections, because prior to Part 2, everything was geographic lat long. OGC features is supported in both 2D and 3D, but more importantly, the OGC feature layer is part of the web map spec. So we can add these layers to web maps, save them to online, and share them with friends and family or colleagues. So I'm going to start with a very basic demonstration of OGC features in a web map, in a map. So we're looking at countries of the world, and we're zooming into Europe. I'm going to display the editor here. So in order to view this, we create a new OGC feature layer. We provide the URL to the landing page and the name of the collection we want to display. In this case, 0. We add the layer to our map. We're specifying we want a satellite space map. And lastly, we add the map to our map view. By default, we get this orange semi-transparent polygon. But because OGC feature layer is basically like a feature layer, we can do a lot of the common things we do with feature layers. For example, labeling and pop-ups. So in this case, the countries now have labels with the country name. And when I click on the country like Poland, I see all the attributes popping up. So the start of this application is just the same. We create a new layer, new OGC layer. We provide the landing page and the name of the collection. But this time we provide the definition of the pop-up. We want the pop-up to have a title with the name of the country, and we want to display these fields from the OGC service. So these are the field names. This is the label we want to see on the pop-up. Next, we want all the countries to be labeled with the name of the country and white text with the black halo. Lastly, let's play with the symbology. So in this case, I want to symbolize the countries based on population, and I have a legend widget in the lower right-hand corner. So again, start the same way, create a layer, add it to a map, add it to a view, but this time I'm going to take advantage of a smart mapping utility to automatically create a renderer for the population. So we're going to provide this function, these parameters. I want it to create a renderer for the population, and I want the range to be between 0 and 200 million. It's going to automatically create the best renderer for me, and then I assign that renderer to the layer. MaxRecordCount is a new property we added. It basically represents the paging limit. This is the maximum number of features that we can request from the server. Unfortunately, the specification is not very clear about how it advertises this amount, so we do our best to determine what it could be. We have a fallback value of 5,000 features, but we give the option of the developer, you guys, to explicitly say what the paging limit is by using the MaxRecordCount. For example, in this case, I'm saying the paging limit is 1,000. So when the layer is drawing, it only requests the first 10,000 features. So 1,000 features. And this is very important in the current release that was released about a week ago, 4.29, because we switched to a paging tiling strategy. This means that we take advantage of paging to request features faster, and we saw an overall performance increase than the previous versions. So this makes the paging limit, the MaxRecordCount, critical for efficient drawing. Now I'm going to go through a demonstration of creating a new map and saving that map to online. I'll do this programmatically. So here we have a base map with some airports. These airports are coming from the OGC Features service. When I click on this button, it's going to save this map to online. So it's asking me for my credentials. And right now it's saving this as a new map to ArcGIS Online and presenting me with a URL to the page for the web map. So I need to log into my account, and I should see the same map. So, and I can open this up in Map Viewer. So I should have the same base map, the same ArcGIS services layer, features layer, same extent. And also open this up in Pro. So again, I should see the same content. You may want to get a cup of coffee. So it's opening up the web map with the base map and the service and the same extent. There we go. So this is the code I used to do it. So I created a new layer. I specified the landing page to the service, and I used the collection called airports, and it provided some metadata, including the copyright statement, and also an elaborate airport symbol using a sim symbol. That layer is added to the web map, and that web map is added to the map view. We added a button to the lower left-hand corner, which when clicked, it's going to save that web map to online. So here's the code for that. So the first thing is when the button's clicked, I want to update the web map with properties from the view. So this basically stores the extent, the current view extent, and puts it into the web map. Then I save the web map to online, and once that's returned, once it's been saved, I get a reference to the portal item. And the portal item includes details which I can use to construct a URL for the user to click on. And they'll lead me to the page for the web map. This is for the road ahead. We intend to work on part 3. This is support for CQL. And what it could look like will be just like other feature layers. We can provide a query, and that query will be evaluated on the server. So in this case, we would provide a query, for example, with a geometry, with a time extent, and a spatial condition. That will be converted behind the scenes into CQL and submitted to the server. And you'll retrieve the features that satisfy those conditions. So even though we don't currently support part 3, you can do queries client-side against client-side graphics. So I gave a presentation on this a few days ago. It's called client-side visualization analysis. So you can use queries for visualization and analysis for the features you've already retrieved from the server. Hisham mentioned map tiles. We currently don't have a dedicated layer for map tiles, but you can view its content using an existing layer we call web tile layer. This is a very generic layer for viewing tiled imagery. All we need to do is provide it with the template URL. So I'm going to go to this landing page for a server that has a lot of content, including map tiles. And it describes here the URL I need to use to obtain map tiles. So it contains the name of the collection, the tile matrix, and also placeholders for the level and the row and column, and also the type of image I want, whether PNG or JPEG. So I'm going to use this information with this layer, the web map tile. So I'm going to go to this demo app. So what you see is the same map tile image that Hisham showed earlier. This is NASA's Blue Marble. It's coming from a map tile service. So I'll show you the code for this. I mentioned the template before. It came from this landing page. I'm specifying one the collection called Blue Marble. This is a map tile layer. I'm using this tile matrix. And these three curly brackets are placeholders. Placeholders for the level, row, and column. And I'm specifying that I'm accessing JPEG images. So this is used in the definition of the web map tile, and we're adding that to the map as a base map. These points were just added just for my personal, just to verify that the tiles were coming to the right place. And that concludes my presentation, and here are some links from our APIs that you may want to access.
Before we open the floor, I think we have 2 minutes. I'm going to show you a cool tool.
Your microphone.
I'll repeat. Before we open the floor for questions, I'd like to show you a cool tool that gives you a look into behind the scene into the web map. Remember, Richie created that web map, and in that web map, we persisted an OGC API feature layer. Let's look at it and show you the tool that you can find online to look at this item and look at it a little bit. So ArcGIS Online Assistant, if you search the web for that, it gives you this site. And all it does, you can log into ArcGIS Online with your credential. And I'm putting here the ID for that web map. And I go and search ArcGIS Online. I get it here. Now, if I want to look at it as a JSON, I want to see the JSON behind it. Click on it over here and go all the way to see the operational layers and the layer definition. I'm going to close the layer definition and notice that the operational layer airports is coming from Zoom STAC, and it's of type, the layer type, I'm gonna enlarge this a little bit, is OGC FeatureLayer. Just to give you a little bit of how different, like we can open it, the same web map can be opened by reading this information in ArcGIS Pro, in any of our native SDK, in JavaScript, in the online map viewer, and so on and so forth. Now we'll open the floor for your questions.
What's the roadmap for supporting vector tiles that are coming from non-Esri?
Great question. So the question was, what is the roadmap for supporting vector tiles? We are working on it right now. The product that is ahead of any other product is ArcGIS Pro. Actually, if you stay after the session a little bit, I can show you how you can add it as a network path and work on it. So we're getting there. It's coming very close. The code right now, I can show you a trick to do it, but it's not official yet. Look for the next version or the one after for that. Definitely, we're heavily working on it. Other question, please?
So what is your roadmap for the Part 4 updates, create the leads of the OGC Features API?
Great question. So the question is, what's the roadmap for Part 4, which is create, update, delete? It's still in draft. Usually, we'd like to see things final, but it's not. We also see the value in jumping in while the spec is still in draft. So we'd like to hear you guys. We'd like to hear from you. If there is a push to get into it right now, we're ready for it. We're keeping an eye when this comes out and it's final. We definitely want to give it a shot. But we'd like to hear more from you on the need for, because in the past, none of our clients supported, for example, if you take WFS, editing or transactions. So now we're evaluating that, but we'd like to hear from you. Would that answer your question? Thank you. Go ahead.
Two questions. First, how does from your perspective, or from the Esri perspective, how does OGC API align with the wider OpenAPI and your strategy for OpenAPI?
Absolutely. So the question, and I'd like Satish maybe who can talk a little bit about the strategy. How would the OpenAPI align with the wider vision in other product at Esri? Satish?
Actually, not that I have a perfect answer for that. So let me just tell you a couple of things that we have seen coming in as requirements, right? So if you look at the Esri REST API, it was born, 10, 12, how many ever years back before OpenAPI was even there, right? So you're noticing even in the plenary here, I think there was a points of interest stuff demonstration that was done. So some of the new work that Esri is doing outside of the OGC space is following the OpenAPI principles. I think the Velocity product, for example, has an OpenAPI interface, and I think there's another one with, I forget the other products. So there are a couple of things. The newer implementations we're working on, we're obviously looking at OpenAPI. The OGC stuff obviously has this OpenAPI connection, so we're doing that. The one area where we're finding a little bit of difficulty is to kind of reimagine all the old stuff that we have in the OpenAPI context. So we are well aligned with OpenAPI going forward. That's how I would see that. Yes.
Please.
Related to that question, do you see the OGC FeatureServer and the FeatureServer merging at any point? So everything is OGC compliant that gets out from ArcGIS server?
Let me see if I can reframe that question. Would you like to see like an open API endpoint which says, I could do it using OGC API features or an Esri feature service or whatever, all living within the open API framework?
Will the Esri feature server be deprecated and there will only be OGC compliant?
Not at all, not at all, not at all, for many, 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 many reasons. But I would also recommend to you to attend, I think, Khaled does a presentation on feature services that kind of clearly explains the amount of investment and research that has gone into the Esri feature services and the variety of things that it supports that the OGC API features does not support. Not from our implementation, but just from a spec perspective even. Yes.
I think just catching what you just said sounds to me more realistic or reasonable would be having an open API layer, which then could give you options towards either OGC or Esri specific APIs. Is that
something that I would like to see happen?
Yeah.
But like I said, we've got enough historical work that has happened to drag them all into this is going to take some time, right?
I did have another quick question just on roadmap. I didn't see anything about OGC API processes. Is that something that you're looking at?
Yeah, that's a good question, right? So again, just going by user requirements and what we're seeing out in the market, if you look at the old OGC stuff, we did a great job at WFS, to some extent with the web coverage services. And when I use the word great job, I'm not talking about from an implementation perspective, but that's where we've seen the focus. With the WPS, for whatever reason, we haven't seen that kind of a push. I'm talking about the old web processing service. So unless things change for the OGC API processes, we may not jump on the bandwagon until we see, what I would consider real customer interest. Yes.
What are the plans regarding CSW, catalog service, and is there anything outside GeoPortal?
So that's a good question, because that's what I think in one of my slides we talked about all the newer stuff that's coming out of OGC. So the OGC API records is in many ways a replacement to the CSW. So that is the one that we are investing in. The hub currently supports OGC API records, but we'd like to see it supported in other parts of the platform where you might want to be, where you might be interested. But a quick one on that, right? So the thing with this is that common pattern. OGC API features is not so very different from OGC API records, which is not so very different from the STAC API, right? So they're all living in that same space, which makes it a lot easier for us to navigate and work on those. So OGC API records would be the one that we would focus on.
So just to wrap that up, so do you have STAC support yet?
We have STAC support in different parts of the stack, in the different parts of the Esri stack or Esri platform. So ArcGIS Pro does offer support today for STAC. We're looking at, on the server side, GeoPortal server, the open source solution that we has played around with STAC. So yes, we are. It is an absolutely important part of our strategy. Yes.
So how's your plan to accommodate with metadata requirements on the feature server?
I'd like to have a longer conversation with you on that stuff, because one of the things is, in many ways, and Dean, jump into this if you can answer this better than I can. I see there's a lot of metadata work that seems to be happening in OGC that doesn't quite tie into some of the OGC API web services stuff, right? Even if you go back to the older ones, there used to be a metadata URL from a WMS service that would just point to a document somewhere. Right? I'm talking a full level metadata, not just the contact name and a few things that are part of the capabilities. So I don't think it's been cracked well enough in the newer specifications of how to put it all together. But it's probably possible, just like, when he showed the conformance page, maybe there's something that says /metadata and it has all that information. So we are, generally speaking, reinvesting resources into our metadata story. Because one of the things that we also realize with all the AI business that's happening out there, it's going to rely tremendously on good metadata. So I think all those people who used to quote unquote hate metadata for various reasons are hopefully coming back into the fold. So as part of that, we'll do a better job. But then of course there's metadata, and then there's all the standards-based metadata. So we got to find some kind of a middle ground that we can all agree on. Correct.
I mean, OGC has a lot of, like you're saying, there's a lot of different initiatives, the guys working on OGC context.
Correct, correct.
Which, I'm not totally clear on how that plays into the new OGC API.
Right. Yes.
Could you say something about the plan of having support for OGC tiles on ArcGIS server, exposing?
Yeah, we have not started work on that, but that is a confirmed, it's a release to standard, so, we should be able to wire it up. I mean, one of the good things with the newer OGC API standards are they're so close to the Esri REST services pattern, if you will. So a lot of it is much more easier for us, what we could consider as real native implementations. So that's something that, we don't have a problem per se of doing, so it's just getting the right resources on it. So.
Okay, if you don't have any more questions, we'd like to you to please fill up the survey and give us feedback. We'll take those really to our heart, and we consider your request. All of these good questions that I heard right now, if you can reiterate them, contact the team here at Esri with these. We'll take it into consideration in our next version and improve our software.
So I'm going to just say one last thing here, right? So typically outside of the OGC space, it's very easy, right? I mean, we do our own research development and we release some stuff where we have real requirements from customers and, they tell us what they really want and we do that. This is slightly, a different world, if you will, right? So there are requirements that don't come in as requirements. There are people that call us and say, we need support for WMTS, we need support for this. And it's not in terms of, here's our workflow and this is what we're doing, right? So that makes this space a little bit more complex. So it also means that we're not necessarily always waiting for requirements. We try to say, okay, this is a spec, it is becoming a standard, organizations are going to be using it, so we'll start working on it. Right? And then we have to make that prioritization decision between, is it a standard or is it just it's a draft standard at this point. But at the same time, there are organizations that might be pushing for certain things. The EDR is getting extremely popular, right? So that is something that we would like to tackle in the very, very near future. Okay.
Thank you, everyone.
Thank you.